All right, in this video, we're going to look at activity 5. This one requires some sketching, so I've switched over to my tablet, which means you're not going to be able to see me in this video, but we'll still be able to get through it. So we're going to be doing some graphing of different functions, and this is meant to sort of be a preliminary for us to work on activity 6, where we're going to then apply this to our circuits. So let's take a quick look at this. Suppose two quantities, x and y, both vary with respect to time, and that x and y are directly proportional. That is, y is equal to a constant times x. The shape of the x versus t graph is shown. Sketch the graph for the y versus t graph, and label the initial and asymptotic values for y. So we want to figure out what it's going to look like for our y versus t. Now we know that we're going to have something that has the same shape because it's proportional, but the size is going to be different. The size of y is going to be increased by this constant c, assuming c is greater than 1. So the shape should be the same, but our values will be different. Let's see what it looks like. All right, so we're going to draw something that has the same shape. Oops. My pen is not working. All right, so same shape, but values. So what is our initial value? The initial value is 0. So 0 at this side. And what is our asymptotic value? At that highest point, that asymptotic value is going to be c times x naught. All right, suppose two quantities, x and y, both vary with respect to t, and the sum of the two quantities is 0. That is, x plus y equals 0. Then the shape of the x versus t is shown. Sketch the graph and label the asymptotic and initial values. So in order to get them to add to 0, they have to be additive inverses, which means our second one is going to be the same shape, but is going to be negative. And so again, we're going to start at 0. And our asymptotic value is going to be minus c times x naught. Or is this one doesn't have the c? I can't remember. I don't think this one has the c. So let me erase that. This one is just minus x naught. All right. All right, and then once again, let's look at the third one here. This time, x plus y is equal to x naught. And so they've got x naught shown there as the asymptotic value for that one. So if we want x and y to add up to x naught, then since the one on the left starts at 0, we're going to have to start at x naught. And we're going to have to end at 0 since this other one ends at x naught. And so they're going to be multiplicative inverses. Oops. Not so wavy, but something like this, where we start off at x naught and our asymptotic value is 0.